Okay, so this video will review how to simplify radical expressions. Remember, the goal in simplifying radical expressions is to find the biggest perfect square factor that we can divide into our radical. So in this case of root 96, square root of 96, I can break that down into the square root of 16 times the square root of 6. 16 is a perfect square, so the square root of 16 is 4. Root 6 is simplified as far as it can go, so therefore our final answer is 4 root 6. Our next problem, we have the square root of 216 in which our biggest perfect square factor of 216 is 36, and 36 times 6 would equal 216. So the square root of 36 is 6. Again, root 6, like our first example here, is simplified as far as it can go. So our final answer is 6 times root 6, or simply 6 root 6. The square root of 45 can be broken down into root 9 times root 5. So again, 9 is a perfect square because the square root of 9 is 3. So I have 3 times root 5. 5 is not a perfect square, cannot be broken down any further. So my final answer is 3 root 5. Okay, in our next two problems, only difference is that there's a number multiplying our radical out front. Our goal is still going to be to simplify our radical first. So we're looking for biggest perfect square that can go into 96 that can be divided into it. In this case, again, is 16. Root 16 times root 6 would equal my 96 again. I'm going to bring this 10 that's out front, that's multiplying our radical, and just write down. I'm going to simplify the square root of 16 because it's a perfect square. I can say that that is 4. Rewrite this. Because the 10 and the 4 do not have a square root sign, so these are not radicals, we can multiply those. 10 times 4 would be 40. So my simplified answer would be 40 times root 6, or 40 root 6. 9 root 245. Again, we're going to look for the biggest perfect square factor of 245. And that would be 49. 49 times 5 is 245. So I can break that down to root 49 times root 5. I'm going to bring the 9 down. Simplify root 49 to 7. So I have 9 times 7 times root 5. These are not radicals, therefore we can multiply them. Simplify it one step further. 9 times 7 is 63 times root 5, or 63 root 5. Okay, next we're going to look at multiplying radicals. We can multiply two radicals with one another. In this case, we have root 2 times root 14. 2 times 14 is 28. So now we have combined it to one radical, so root 28. We're going to use the same exact concepts from the previous slides and try to simplify this further. We're looking for a perfect square, the biggest perfect square factor of 28, in this case, 4. So the square root of 4 times the square root of 7 would equal root 28. Root 4, square root of 4 is 2 times root 7, or 2 root 7. Next example, we have root 6 times root 8. I'm going to multiply these two to make a single radical, which in this case is the square root of 48. Next, we're going to try to find the biggest perfect square factor of 48, which would be 16. Root 16 times root 3 is the square root of 48. 16, we're going to simplify that to 4. 4 times root 3, or 4 root 3. Now we have simplifying radicals with variables. And there's not much difference between these types of problems and the previous problems that we just completed. The only thing that is different is obviously the fact that we have variables involved. So what I like to do is just kind of break these up into little mini problems with the radicals. I'm going to say that this is root 90 times root x to the third times root y to the fourth times root z to the fifth. I'm going to look at simplifying these each individually. So the biggest perfect square factor of 90 is 16. So 16 times 5, root 16 times root 5 is root 90. Root x to the third, biggest perfect square factor of x to the third is x squared. Root y to the fourth is actually a perfect square. I can take the square root of root y to the fourth, which is y squared. Root z to the fifth, the biggest perfect square factor of z to the fifth is z to the fourth. So z to the fourth times z is z to the fifth. So now let's just keep simplifying here. 16, the square root of 16 is 4. So I have 4 times root 5, so root 5 is done. The square root of x squared is x. Root x is done. We have y squared. The square root of z to the fourth is z squared. And root z is done. So now everything that does not have a radical, that is not a radical, all those numbers, we have 4x, y squared, z squared. I'm going to simplify those and say that is 4x, y, z squared. Excuse me, 4x, y squared, z squared. 4x, y squared, z squared. All the factors containing a radical, root 5, root x, root z, go underneath together. And we have now simplified our problem. And one more. Again, when dealing with radicals and variables, let's make these into a couple mini problems here. We have root 32 times root r squared times root k to the fourth times root t to the fifth. Okay, a simple little trick when taking the square root of a variable that has an even exponent would be to just cut that exponent in half. So let's start with root 32. Again, perfect square factor. Root 16. Since this is an even exponent, the square root of it would just be to cut it in half. So that would be r to the first, or just r. So that is a perfect square. Same goes for root k to the fourth, because k to the fourth is k squared times k squared. So the square root of root k to the fourth is k squared. Now root t to the fifth is not a perfect square because our exponent is an odd number, it's 5. So I need to break that down a little bit further and find that perfect square factor. In this case, it's t to the fourth. So when dealing with an odd exponent, the perfect square factor of it is just going to be one number lower. So the perfect square factor of t to the fifth is t to the fourth, and then I times it by the root t. Okay, we're going to simplify a little bit further here. Square root of 16 is 4. Root 2 is done. I have times r times k squared. Square root of t to the 4th is t squared. And then I have root t. Now we're going to put it all together. The numbers that are not radicals, 4, r, k squared, t squared, I'm going to set outside. 4, r, k squared, t squared, right? 4, r, k squared, t squared. And then the radicals all go underneath the root, 2t. And we are now done.